A very warm welcome to Deeksha Vedantu YouTube channel. I hope all my 10th champions are doing really great. But I want you to let me know one thing in the comment section. How many of you look at the word ray diagrams and your mind goes blank? You don't know the shape of concave mirror. You don't know what shape is of convex lens or concave lens. But okay, ma'am, I know where the image is formed, where the object is placed, where the image is formed, the size of image, real, inverted, virtual, erect, everything. But when I try to make that ray diagram, my rays don't converge at the point of image. What should I do about that? I've crammed everything now. Whatever there is to learn, I've learned everything. How do I make the rays converge at the point of image? Correct? Am I a little bit correct? Let me remind you, you are not alone. Well, first you just need practice. But practice should be in the right direction, right, my kids? So, I'm going to give you that right direction in this video today. A correct step-by-step approach on how to solve all the ray diagrams that is there in 10th class. I know you get feared by them a little bit, but after this video, that won't happen. So, let's start with the very basic. What is concave mirror? What is convex mirror? So, I'll give you one trick to remember what is concave mirror. Okay? Concave mirror, break that word. What is it? Concave. The other one is cave. What is it? A cave. A cave, a tunnel. Does this look like a cave to you? Correct? The inner portion. The inner portion, does this look like a cave to you? It does, a little bit, right? If I trick my brain into thinking that it is a cave, then it is a cave. Ma'am, this one also looks like a cave on the other side. But this is where you need to differentiate these two. In concave mirror, the light is going inside the cave. The light rays are going inside the cave, like a lion goes inside his cave. The light rays are going inside the cave, and the inside part of the concave mirror is the reflecting part. Correct? On the convex mirror, it does look like a cave from the other side, but the light is now outside of the cave. On the other side of the cave, it is reflecting on the outer part of our cave. Correct? That is solved. Now you will remember what is concave mirror, what is convex mirror. Concave mirror, concave means cave, and my light is going inside the cave. Okay, that is concave, and then you can just flip the mirror and you will know what is convex. Then, now the trick to solve concave mirror. Before that, okay, let's see this. I'll give you one very important trick to solve every case of concave mirror. And you'll thank me in the comment section. Okay, this I'll make a concave mirror first, and this outer part is not reflecting, so I'll shade that. So my inner part is reflecting. I'll make a principal axis. This is my pole, this is my focus, this is my center of curvature. What I need you to do, I want you to write 1, 2, 3, 4, 5 above the principal axis, and then I want you to write 1, 2, 3, 4, 5 in reverse section below the principal axis. Let me show how. But where should I write these 1, 2, 3 numbers? At the position of object. At the position of object. So on the upper side of principal axis, I'll write 1, which is at infinity, 2, which is beyond C, 3, which is at C, 4, which is between C and F, and 5, which is at F. Now what did I tell you? Write 1, 2, 3, 4, 5 in the reverse direction below the principal axis. So under 5, I'll write 1. Under 4, I write 2. Under 3, I'll write 3 again. Under 4, under 2, I'll write 4. And at infinity, where my object was 1, I'll write 5. And this is my image. So this is the position of object, this is the position of image. Let me show you how this works. Object at infinity, image at focus. Object beyond C, image between C and F. Object at center of curvature, image at center of curvature. Object between C and F, my image will be beyond C. Object at focus, and my image will be at infinity. Correct? It's very easy now. There is one more case, which is my object is between focus and principal, that you can just remember that in the sixth case it forms on the other side of the mirror, which is virtual and direct. Now I want you to remember two important things first. For concave mirror, the image is real, the image is inverted, and let me tell you, I have explained why the image is real and why it is inverted in my rapid revision in my one shots. So you can go see those videos too as well. Okay, so for concave, my image is real and inverted and of different sizes, bigger, smaller than object, bigger than object, all kind of sizes. For convex, my image is always virtual and erect. For this we have 5 cases, but for the sixth case it also forms virtual and erect image. Okay, we'll see just in 2 minutes. Just you need to remember these things. Okay, and in case of convex mirror, the image is always diminished. The size of image is always less than the size of my object. Correct? Now I will tell you four short right approached basic steps that you need to know to make your ray diagrams crisp and clear. First, your step is that follow the trick. What it will do, you will know exactly the exact position of object as well as image. What this trick will do to you, it will tell you the exact position of object and image. Okay, you know the trick, now you follow the trick. Make those object and image in your ray diagram first. Firstly, you need to make the object and image. No rays, no nothing. Make a concave mirror, make principal axis, and then make those objects and images. Correct? Now, the third step is, now you make the light rays. Make the light rays. After making your object and image, you will make your light rays. And fourth, don't ever forget arrows, my friend. Okay, so now you know 4 steps. First, you follow the trick. What this trick will tell you? The position of object and image. Then make that object and image on the principal axis with your mirror. Then third subject is, you need to make those light rays now. That I'll show you how to. And then fourth step is to not forget ever the arrows. Let's see. Firstly, my object is at infinity. From infinity, I know all my rays will come to parallel. This is center of curvature, focus. I know when rays come parallel, they converge at focus. This is my focus. I need you to use scale. Always use scale while making ray diagrams. Now this is concave mirror. I know the image will be real, the image will be inverted, and the image is formed at focus. The image was formed at focus, and in this case my image will be point sized. Correct? My image is point sized. Then again you made a concave mirror. This is pole, this is focus, this is center of curvature. Now my object is not at infinity, it has been brought closer to the mirror, and now it is at beyond C. Okay, one ray will come parallel, it will pass from focus. Oh, I forgot. First, we need not to make light rays. First, we need to make object and image. Now follow this trick. If the object is beyond C, the image is between C and F. Also, I want you to remember just one more thing. The size. Here, the size of the object will be same, let's say. But at focus, we saw the size of image was point sized. When we move object closer to the mirror, the object will get bigger, the image will get bigger, right? So in this case, the image will be bigger, but its size will be still smaller than the object. And then at curvature, we know it's same size. Beyond curvature, it will increase. The size of image will be greater than size of object. So what I'm trying to do, as you bring the object closer to the mirror, the size of the image will keep increasing. Okay, as the object is getting closer, the size of the image will get increased. Okay, let's see now. Now it's beyond C. So this is my object. This now what we saw, the size of the image is little bigger but still smaller than the object. So I'll make the image first. Okay, I'll make the position of image first. Now I'll make the ray diagrams. Now I'll make the light rays. It should be a little smaller. Now I'll make the light rays. What I'll do, one ray parallel to principal axis, it will pass from focus, but it should also cut at this point, right? So place your scale and make sure it cuts the image at this point where you made the image. Okay, then make a line parallel under the principal axis from the image. Make a line parallel to principal axis. Place your scale at this point and join it to this point, and it should pass from focus. Join these 3 points, and hence your ray diagram is perfect. This is your object, this is your image. Now this is also real, correct? This is inverted. We can see this is inverted, and this is of small size, or you can say diminished. Okay, so this image, and it is between C and F, correct? Let's move on to the next, at C. Now at C, I clearly remember from the trick that when my object is at C, the image will also be at C. And I know when my object is placed at center of curvature, the size of image will be equal to the size of object, correct? So under this, I will also make one image which is of same size at the same position. This is my center of curvature, this is my focus. Again, what I'll do, one ray parallel, and it should cut my image at this point. So this will pass from focus and at this point. One ray I will make parallel again, and now I will connect these 2 points. Then don't forget the arrows. So this is going here and here, correct? We just made an image very easily, guys. Okay, here my image is at C, it is real, it is inverted, and it is of same size as of object. Correct? Good to go. Next, now between C and F, my object is between C and F. Now here the size of object is same. If I bring my object closer to the mirror, the size will increase. And from my trick, I know if object is between C and F, image will be beyond C. So I will make an image which is beyond C. And I will make it a bit larger because I know the size of the image is increasing. So this is C, this is F. What I'll do, one ray parallel, it should meet, these 2 points should meet and pass to focus, and another ray, this is parallel, and this also should connect and pass through focus. Don't forget the arrows. This ray is getting reflected back. This ray is going to the mirror, reflects back, meet at this point. It's that easy. Okay, and here it is, the image is beyond C, correct? Real, inverted, and my image is now larger in size. Okay, correct? Let's move on to the next. Now I brought my object closer. It is at focus now, at focus. Now with the trick, I know if the object is at focus, the image will be at infinity. So I'll just use that. The image will be at infinity. I don't need to make that. I'll just make a ray parallel. It passes through focus. Then I'll make another ray which goes from pole and it goes till infinity. It goes till infinity. Is it correct? So these are the arrows going, getting reflected back, going, reflected back. In this case, see, the object is at focus, so the ray of light cannot pass through focus, right? So we read another rule that whenever a light ray hits the pole, it gets reflected back at the same angle. So we are using that here. Okay. In here, the image is at infinity. Image is at infinity. It's again real and inverted, and it's extremely large. Now at focus, the image will be extremely large. Correct? Till now it's true. Now let's come to the exceptional case. Now here the image is between focus and pole. This you just need to remember very carefully. What will happen? This ray will go parallel, comes back and passes from focus. Now another ray will go to the pole and will go and will reflect like this. And these are my arrows. But see one thing, these rays are getting apart. Okay, the distance between them is increasing. Here the distance remained same. That's why we said that image will become at infinity. But here the distance is increasing, so these rays will never converge. So what we do is, instead we extend them behind the mirror, and because we are still seeing the object, so there is some reason behind the we are still seeing the image, so there is some reason why the image is still getting formed. So this is the reason, because in this case we saw that the image was erect, because in this case the image was inverted. But in this case, between focus and pole, we saw that for concave mirror between focus and pole the image is virtual and erect. We are seeing a man, erect image of a man, okay, not the inverted one. So we saw that it is making the image is being made behind the mirror. So in this case, my image is virtual, it's erect, and it's behind the mirror. The image is behind the mirror. It's virtual, it's erect, and it's large in size. Not extremely large, just simple large. Now you're done with concave mirror. Let's move on to the convex mirror. This is your summary. Okay, for the concave mirror, at infinity the object is at focus. Beyond C, the image is at image is between C and F. At C, the image is at C again. Then between C and F, if my object is between C and F, if my object is between C and F, my image is at beyond C and it's large. If here at focus, my image is at infinity, and in this case my image is, this is between focus and pole, so it is virtual, erect and large. Okay, let's move on to the convex mirror. We just have two cases that you need to remember. Now in convex mirror, this is the shape. Do you remember the shape of convex mirror? What is happening is, when the object is at, not F, it is at infinity. If the rays are coming from infinity and hitting the convex mirror, these rays are coming parallel. So instead of getting reflected like this, they are getting reflected away. This is coming again from parallel and it's going this. Now these two rays will never meet, right? So we extend them back, and when we saw where they are meeting, it's again focus. So this is the focus of convex mirror. This is convex mirror. Sorry. So at infinity, my image is at focus. Now, at any point on the principal axis, be it focus, at curvature, beyond curvature, between C and F, at pole, wherever, if my object is on the principal axis or at any point, what will happen? A ray will go parallel and it will get reflected like this. And what we'll do when we extend it backward, we saw this is the focus, and then a ray goes parallel. Now here is a very important part. This you need to remember, if my ray passes from center of curvature, it reflects back and comes back in the same direction. So this is the ray, my ray is going like this, and it hits this point and it comes back in the same direction. So we were worried, why is there no reflection? So when we extended the ray backward, we saw, oh, it's hitting center of curvature, and we know if it's hitting center of curvature, it will follow the same path after reflection. So this is now my image, this was my object. In both the cases, the image will be virtual, the image will be erect, and the image will always be diminished in case of convex mirror. And in case of here, it's only point sized, which is also a kind of diminished image. Okay, so for concave mirror, real, inverted of all sizes. For convex mirror, virtual, erect, diminished. But there is one case for concave mirror which is virtual, erect, but enlarged in this case. So for concave, virtual, erect, enlarged, one case. For convex, virtual, erect, diminished, always. Correct? We're done with the mirrors. Now you'll remember, concave mirror can make both real and inverted and virtual and erect image, but it makes larger image when it makes virtual and erect image. On the other hand, convex mirror always make virtual and erect image, but always diminished. Okay, let's move on to the lenses now. So first we see convex lens. Now convex lens, you can just remember, okay, this is a convex lens and this is my concave lens. Again, you can see this is kind of a cave, so you can see this is concave lens and this is my convex lens. A cave, so you can see caves on both sides. Correct? Light is going in from here. You can see caves from both sides. That is concave mirror. Where caves are closed, that is convex mirror. Done? Now again, convex mirror is similar to concave. Convex lens is similar to concave mirror and concave lens is similar to convex mirror. Let's see how. Let's see for convex lens. Again, in the first point we have at infinity, rays are coming parallel, and now this is a lens. The rays will not reflect, the rays will refract, right? So the rays get bent and they focus at they converge at focus. So when my object is at infinity, the rays will converge at focus, same as concave mirror. Then we brought our object closer, beyond. Now here, instead of center of curvature, we are calling it as 2f. This is f, this is 2f. Anyway, center of curvature is double the focal length. So this here we are not writing center of curvature, we are writing 2f. Now the object is beyond 2f, just like concave mirror. And the image was being made between center of curvature and focus. So here also the image is between f2 and 2f2. Here we are taking focus and 2f1 as 1. There f2 and 2f2. Correct? Now beyond C, what is happening? We will make image between f1 and f2. You can make anywhere, there is no certain point on between f2 and 2f2. What will happen? A ray will go parallel, will pass from the focus and should hit your image. So this is how the rays goes. And in this case, remember, this is optical center. So just like in case of mirror, when a ray hit the center of passes from center of curvature, it reflects back, follows the same path. In the case of lenses, when a light ray passes from optical center, which is the center of my lens, if it passes from optical center, it will not get refract and it will follow the same path. So one ray will go from optical center and it should meet here. So this is where it is meeting, and hence this is my image between F2 and 2F2. Let's move on to the next. Now at 2F2, just like center of curvature, the image will also be at center of curvature and it will be of same size. Just like that, here also at F2, when we have object at F2, the image will be made at F2. One ray will come parallel, refracts, passes from focus and meet at my image. The another goes from optical center again and it travels the same path and meets my image. Correct? Again, between F1 and 2F1, the object is more closer to my convex lens now. Again, now it fits between F and 2F. There it will be, the image will be beyond 2F2, just like beyond center of curvature. So we will make one image here and we know the image will be very large. So one ray will go parallel, passes from focus, meets the image. So I'll just take my scale and make this, and from optical center, so I'll join this point and this point. So this will go parallel. It's that simple. Okay. Next is next is the object is more closer to the lens, which is at focus. Now at focus, we know the image will be at infinity. So one ray will come parallel, passes from focus, another will go from optical center, and the distance between these two remains same. So the image will be formed at infinity. Last, again, this is an exceptional case. Now in this case, my object is between F1 and optical center, not the pole here but the optical center. So one ray will go parallel, another will, and it will refract and passes through focus. The other ray will go back into the optical center. Now we can see actually these rays will start going away from each other. So what we do, we extend them back, and we see that this large image is being made. Now in case of convex lens as well, just like concave mirror, the image was real inverted of same sizes. Here also in convex lens, concave mirror, convex lens, the image will be real inverted and will be of same sizes. There also the sixth case was virtual erect large. Here also the sixth case is virtual erect and large. Correct? Understood? Concave mirror done, convex mirror done, convex lens done. Let's move to concave lens. Now concave lens also just have two cases, just like convex mirror. So first is the object is at infinity, so rays are coming, and just like convex mirror, instead of converging, they get diverged, they goes away. So what we do is we extend them back, and we saw that they are meeting at focus. So my image is being made at focus in this case. Again, when the object is at infinity, again this is wrong. When the object is at infinity, my image will be at focus. For concave lens, for everything actually, concave lens, convex lens, concave mirror, convex mirror, for everything, when the object is at infinity, image will be at focus. Correct? Now at any point, and we took one point between 2F2 and 2F1 and F1. You can take any point on this concave lens. There is the object and one ray. In this case, you can make the rays first, okay, because it doesn't matter the position of object. Just know that it will make diminished image. In convex lens was making all kind of images. Now remember, concave mirror was making all sizes of images, but convex mirror was always making diminished image. So in here, convex mirror means concave lens, so concave lens will also always make diminished image. So one ray parallel, gets diverged, passes through focus, another ray goes from focus, goes straight, and this will be my image, which is virtual, which is erect, which is diminished. In case of convex lens, my images are real, inverted, of same sizes. One case is virtual, erect and large. In concave lens, all will be virtual, erect and diminished. Correct? Everything is done. Any doubt? Let's just make a summary, okay? Let's say concave mirror and convex mirror, and here we'll do concave lens and convex lens. Correct? Okay, for concave mirror it will always be real, and not always, it will be real inverted for 5 cases. For one case it will be virtual, it will image will be virtual, erect and large. Okay, done. Here it will be of all sizes, same size, point size, enlarged, diminished, everything. For convex mirror it will always be virtual, erect and diminished. It will never be, convex mirror will never make a large image, and that's how you can differentiate it's virtual, enlarged, virtual, erect and large, that is concave mirror. Virtual, erect, diminished, that is convex mirror. In case of concave lens, again it will be always virtual, it will always be erect and it will always be diminished. Okay, it will always be diminished. Again, convex lens, it will make real, inverted and all sizes, but for 5 cases. But for one case it will make virtual, erect and large image. You can take a screenshot of this and it will be very helpful for you. All kinds of the nature of images being depicted in this chart, the size of image that can be formed by each of the mirror and each of the lens is depicted in this slide here. And that's it. We have done ray diagrams, all the ray diagrams, and you're done with ray diagrams. You just follow those 4 simple steps. First, the trick. Then you make the image and object for all mirrors and all lenses. First make image and object. Then you make those light rays, and at the end don't forget to make the arrows. That's it for this video. I'll meet you in the next video, which I am doing probably all the formulas of physics in just single video, which I hope will be very useful for you guys. And we are also going live for you, my kids, where we solve tons of questions of all the subjects of 10th class for your CBSE boards. So make sure you join our WhatsApp channel, where we constantly give notifications about these videos, about any polls, about your any related query, about your queries. Yes, okay, so follow this channel and also subscribe our Deeksha Vedantu channel. We are working very hard for you guys for your boards, so make sure you subscribe the channel. So until the next video, tada, bye bye.